Hello, I'm Mrs. J, and today we're going to cover solving a polynomial inequality of problem type 1. Now, it's already in factored form and has set less than 0. Since it is an inequality, we will have to do sign analysis. But at least it's already factored, so we just set each of them equal to 0 and solve. So we get -2, 3, and -8. I'll just put it here. So -8, -2, and 3. All of these will have an open circle because of the less than. And then we put our factors here. X plus 2, x minus 3, and x plus 8. So if we choose a number to the left, -9, -9 and 2 is negative, -9 and -3 is negative, and -9 plus 8 is negative. Multiplying 3 negatives gives us a negative. Then you do the same thing between -8 and -2. We could do -4. That would be negative, negative, and positive. Multiplying these together, we get a positive. Between -2 and 3, we could use 0, which is positive, negative, and positive. This gives us a negative. So you're just plugging the value in here and listing if it's a positive or a negative answer. And then the last one, anything greater than 3, so I could use 3, which would be positive, greater than 3. I could use 10. Positive, positive, positive. And if we multiply 3 positives, we get a positive. This was less than 0, so we want less than is negative. We want this one and this one. In interval notation, -infinity to -8, parenthesis because it's not including it, union with -2 to 3. And that would be your answer. Try another one. Oops. We have setting each of those equal, well, let me write it first. X plus 4, x plus 9, 5 minus x, all greater than or equal to 0. So setting them equal to 0, we get x equals -4, x equals -9, and x equals, adding the x over, x equals 5. So then we need to plug it into these. And we're using -4, oops, -9. These should be in increasing order because that's a -9. So testing points, we could do -10. This would be negative. -10 and 9 is negative. -10 plugged in here actually makes it a positive. Multiplying these, we have positives here. Between -9 and 4, we could do -6, negative, a positive, and a positive. Multiplying these, we get a negative. Now, unless there's a double root or an even multiplicity, these should alternate. We can do a 0, we get a positive, and a positive, which gives us a positive. And the last one above 5, 10, positive, positive, negative. Multiplying, we get a negative. These were greater than or equal to. Because of the equal to, these will be colored in circles. And because of the greater than, we want the positives. So that's this one and this one. Negative infinity to negative 9, square bracket because we're including it. And then a negative 4 to 5. Both of those are also square brackets. It says some of them, there's no solution. Let's see if we can get one to come up. These will all have a solution. Let's make sure we're not getting the same one. Okay, let's try this one. So, x minus 5, x minus 2, and x plus 7. Setting them each equal to 0, we get 5, 2, and negative 7. So we have x minus 5, x minus 2, and x plus 7. And our value is negative 7, 2, and 5. It has the equal to, so we are including them. And you need to pick a number to the left of negative 7, say negative 10. If we plug them in, negative 10 and a negative 5 is negative. Negative 10 minus 2, negative. Negative 10 plus 7 is negative. Multiplying them all together, we get a negative. Between negative 7 and 2, we can use 0. 0 minus 5 is negative. 0 minus 2 is negative. 0 plus 7 is positive. Between 2 and 5, we can try 3. Negative. 3 minus 2 is positive, and 3 plus 7 is positive. Multiplying these, we get negative. And greater than 5, we can use 10. 10 minus 5 is still positive. 10 minus 2 is positive. And the last one is positive. Multiplying these, we get a positive. We wanted less than or equal to, so we want the negatives. So our answer is negative infinity to negative 7, including the negative 7, so it's a square bracket. And then 2 to 5. And those are also including. There's one other one I wanted to include here. It is this one. I was thinking we did these already. Solving a rational inequality problem type 2. Okay, so we have this. First thing we need to do is get it set equal to 0 and then get common denominators. So we have x over x plus 1 minus 3 minus x over 1 minus x less than or just less than 0. Common denominator would be these two. Okay, so this one needs to get multiplied by 1 minus x, and the other one needs to get multiplied by x plus 1. So distributing, we have x minus x squared, And then we have minus 3x plus 3 minus x squared minus x. All over, leave the bottom factored. We got to distribute that negative. Rather than rewriting it, I'm going to make this a positive, and then that will change my signs. So my x squareds cancel. And then I have x, a negative 3x, and a positive x, which just gives me negative x minus 3. Make sure this x squared and this one cancel. Negative, these two is 2x, and that one makes it a negative x. So you have this, and it's all less than 0. To find the quantities, we remember to set the top and bottom equal to 0. So I'm going to add the 3 over, the x. That way it's just solved. This one I'll subtract the 1. And this one, again, I'll bring the x over. So I have 1, negative 1, and negative 3. We have negative 3. Oh, sorry, I can't see it all. Sorry about that. So we have these 3 values. We want to put them in increasing order. So negative 3, negative 1, and 1. Now it's less than, so none of these are included. But if it was equal to, I would only include the one on the top, not the 2 on the bottom, because you can't have 0 in the denominator. So they would still have an open circle. But in this case, there's no equal to, so they're all open circle. Then we want to test. Plug in negative 4. Negative 4 makes this a positive 4 minus 3, so this is positive. Negative 4 plus 1 is negative. And 1 minus a negative 4, that's going to be positive. Multiplying them, I get a negative. Here we can plug in negative 2. Plugging in negative 2, we have a negative, and a positive. Multiplying, I get a positive. In between here, I can plug in 0, which is negative, positive, positive, which gives me a negative. And greater than 1, I could plug in 5, which negative 5 minus 3 is negative. Negative 5 and 1 is a negative, and this would become a positive. Multiplying them, I get a positive. For the solution, I wanted negative, so it's this one and this one. Negative infinity to negative 3 and negative 1 to 1. They're all parentheses because of the open circles. Let's try one more. Okay, so we have 10 over x plus 4 greater than 3 minus x. Get it set equal to 0. So So we have a minus 3. Well, I guess that doesn't matter. Minus 3 and a plus x. Need to get a common denominator. I'm going to make a little room here. So we have x plus 4 over x plus 4. And then x plus 4 over x plus 4. So we have 10, distributing the 3, negative 3x minus 12. Distributing the x, I have a positive x squared plus 4x. All over x plus 4. Combine like terms, I have x squared plus x minus 2. Okay. Then we want to set them equal to 0. X, well, I'm going to factor that first. It factors into x plus 2 and x minus 1. Yes. So setting them equal to 0, I get negative 2, a positive 1, and a negative 4. Using sign analysis, x plus 2, x minus 1, and x plus 4. Negative 4, negative 2, and 1. If this was equal to, then the top two, these two would be colored in. But this would still remain open because you can't have 0 in the denominator. In this case, then equal to is not there, so all 3 are open. Plugging in a value to the left, negative 5. Negative 5 plus 2 is negative. Negative 5 minus 1 is negative. And negative 5 plus 4 is also negative. Multiplying them, negative. We can plug in negative 3. Negative 3 plus 2 is negative. Negative, but this one would be positive. Multiplying them, positive. Between here, you can plug in 0. You get positive, negative, positive. Multiplying them is negative. And greater than 1, say 2. Positive, 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 which is a positive. We wanted greater than 0, so it will be this one, because plus, and this one. Negative 4 to negative 2, union 1 to infinity. And that's all it's to those.